let's see how to create our own root certificate and use that root certificate to sign another host certificate, such as I will give an example of my network attached storage. That's a Synology NAS that I will create a certificate request from and sign that request with my own self-signed root certificate. It can be useful to have signed certificate even on your private network, because when you do access, for example, my NAS, I mean, I get this annoying text all the time, your connection is not private, and that is due to we don't have any valid certificate. So in Windows, I have these trusted root certificates, and whenever I go to some host somewhere, if that certificate is not signed with any of my Windows trusted root certificates, I will get this screen. So now we will try to fix this. And yeah, first of all, I need to download OpenSSL. Since I'm running on Windows now, we can do that from wiki, openssl.org. And in the binaries, I have a number of different versions to choose from. I normally go with the 5daemon here. I will do it today as well. And I will download the zip file, and it will be the long-term stable or support file that I will choose. That is 3.0.15, version 3.0.15. Yep, so that is downloaded into our folder. I downloaded it before, so I can just delete that one. So delete these as well. Let's see. I'm going to use them later on. Yeah, you need to unpack the files. I have them already unpacked here, and then I need to copy them onto my drive. And let's do that. I will create a folder. Call that folder OpenSSL, for example. It's a good name. And I need to copy first the SSL files, which is the configuration files. Even though I don't configure anything, I just leave it default, but you can have it if you want to configure things. And then I need the other binaries and stuff like that. And I paste it here. So yeah, like that. And that is the x64 binaries, of course. So now I do have my OpenSSL downloaded. Let's open a command prompt. Run as administrator. And let's move to that folder. cd OpenSSL. And in that folder, I will just create a batch file. Okay, so set vars.cmd, for example, set variables, and I will try to paste here if I can do that. Paste, yes. So yeah, what this do here? I set OpenSSL home variable to my path, and I set the configuration, the path to the configuration file, and also I expand the Windows path environment. So by doing that, so let's make sure we save that file, and also I will just verify I have this thing in there, so you can see if I run OpenSSL version, it just said it's not recognized, and that is why I don't have run my variables yet. Let's try it again, OpenSSL version, so now it can find the binaries, and I can see that I am running 3015 there. That's good. And the next thing to do is we should create our own password string and save it to a text file. So I will, I can do it like this. My or password 123. That would be my secret password, and I will just save it to a text file like that, and verify that we have. Yes, so you see it contains a string, password 123, and the next thing is to create or generate a private key for our certificate, and I will be using the RSA. Let's see if I can paste it there. Yes, the RSA crypto system, which is the most common one to use. And what else? Yeah, you can see that I have the switch genpkey, which generate private key, and I save the private key as rootca underscore key.pem, because I will use PEM format for this one, and I will use the newly created password file as input as well, and I'm using a 1496 bits length of this private key, and yeah, what else? Yeah, some ciphers AES256 to encrypt the file as well. So yeah, I will add these commands in the description below as well, so you can copy it from there. So I just run that one, and hopefully it has created what we need. So an easy way to check it is to just use the newly created rootca key.pem file and use the check parameter and some else noout. I don't want to pass the content out there. So I mean, and the file I need, of course, the password. So yeah, so it says RSA key OK. So now we have verified it. Now we should create our self-signed certificate, and we do it by specifying OpenSSL request new certificate, and it's the X509 that creates this certificate. And the format is PEM, and I'm using SHA-512, and I set the expire date to 30 years ahead. That is 10,950 days. and passing in the password file and my private key, and out I will save it as rootca_server.pem. Yeah, like that. And of course I need to input. You can also have all of these in some configuration file that you might save in OpenSSL, but now I will just give them here instead. It's easy enough. Locality, I don't need that. Yeah, XP Gaming Company. Organizational unit, I skipped that one. A common name, I mean, you should use some name for this one. I'm using like XPIT root CA, so I know what kind of certificate it is when I'm looking at it in later on in Windows certificate console. Email address, yeah, you specify your email. Some email at here.com, like that. Okay, so also let's check this one, and we do it with the check command as well. So now we can see this is just the encrypted things. So let's go up to our parameters. Here we can see that we have country, we have state, and we have organization, common name, and email address here. And they have valid expiry dates and so on. So that's great. It looks good, and since Windows is not using PEM format, we can convert it to a format that Windows recognize easily. So that would be a binary certificate. So just by out format DER, that's the Windows binary format. So let's check if we did get that file. Yeah, so you can see we have it here. And also, if I check that one, here you can see that Windows recognize this one. And here also I can check all the details I'm was using as input to the file. So in a graphic format. But now let's install it in the management console. And it should be trusted root certificate. And I choose the import task and browse to the folder. Yes, we have it here, and it's that certificate. And I'll just click next and next, finish. Okay, it says it was successful. Just let us see here. So here it is. And if I open it now, we can see that this certificate is okay. So now it's in the trusted store container here. So that means this one is it's our root certificate now. And all the other certificates that we sign using this one will also be trusted from our Windows host now, since we imported it to the trusted root certificates. I will later on as well use this as my iPhone and iPad and so on, and also a Mac. So I will import it later on, but that's not for this one. Now I'm in Windows doing it. So let's continue here. So now the first part is done. We have our root CA certificate, and the next thing would be to create a certificate request from our NAS, and yeah, I need to log on to that server. So I go to Control Panel, Security, and Certificate here. I do have a certificate, of course. It's the default self-signed certificate generated by the NAS itself. But since my Windows machine isn't trusting this certificate, it won't help. So I need a certificate that is trusted by my Windows machine, or by my root certificate, that is. So let's create a certificate request. So if I go to Settings, Advanced, create certificate signing request, and the procedure here is same for if you are using your own private signed root CA, or if you are using some public certificate authority. And yeah, you need to pay, of course, for that one, but you create the request here as well. So I choose the highest key length, like that, and the common name for my NAS, and I have some email, some mail at here.com, for example, and location. I'm currently in Sweden, so I'm choosing Sweden. State, Stockholm. I think this one I need to put all of these, otherwise I cannot continue. So let's see, Xbit Gaming Company and department. Well, gaming department would be fine, I guess. Next, and now it creates the request for us. Take some time. Okay, so now we need to download those. Great. Now I have downloaded those here, archive, and let's extract that request. Okay, so here we have it, certificate server request and the key for that one. So I copy those, and I go back to my OpenSSL folder. Okay, I paste them here, and I will rename them so I can keep track of them. So I know that they are from the NAS. Okay. Next, I need to add some configuration to use when I do the signing. So let's create a configuration file for that. Just a text file, that is. You can name it whatever you want. It is the content that is more important. So let's have a look here. So the authority key identifier, this one is needed because we are going to sign, and the key usage, this is default for almost all certificates, and the most important here is the extended key usage, server authentication. So since this one is an SSL certificate. Yes, and I have added a comment, and I have some alternative names. I'm using 3 alternative names. That would be my fully qualified domain name, my host name, and my IP address. So let's save this one. Save like that. And let's see. Oh, yeah, okay. I don't know why it did like that, but let's see now. So I have the conf text. I have all the certificates now in place, and that means I can move on to create a signed certificate. So I need to paste, it's a long one, this one. So I'm using my NAS certificate request as input, and I'm using my root CA certificate for the signing purpose. And for that, I also need a key for my root CA, and it should create some serial there and should output NAS underscore signed.pem. And I set this one to expire after 10 years. You can set whatever you like there. And yeah, I'm using my configuration text file and also the password for the root CA key file. So let's try running this one. Certificate request self-signature, okay. So that means we should now have our certificates. So let's go back to our NAS server. Now, since we are having everything we need, we have the signed certificate and we have the private key for that as well. So now we need to add that certificate, and the easiest way to do this is to replace existing. If you don't want to do it, you can of course choose add, and then you will have both of the certificates here. So I will replace the existing called Synology like that, and click next. And it's of course import. I will just call it NAS, and yeah, set this as default as well. And then click next, and private key. And the private key is NAS key, as I renamed it to. And the certificate is signed, NAS signed. Okay, and then click OK. So now it will install this certificate. It will restart the web service for the NAS. And then hopefully everything will work. But we'll see about that. So now the web service has been restarted. So I need to move away from there. And let's try with the IP address first. Yes, okay, so it logged on. Well, I can of course log out, sign out here. I don't need to be logged on there, but I did notice that it looked okay. We can see here as well. The connection is secure. This site has a valid certificate issued by a trusted authority. How cool is that? And you can see here in the details, in the certificate hierarchy, here is a host certificate NAS, and here is the root certificate used for signing. And since we are having this as a trusted certificate in Windows, we automatically also trust this NAS host certificate. So great. And it should work also with the host name. So it looks okay. Yeah, connection is secure. This site has a valid certificate. Great. And let's try the fully qualified domain name as well. And that would be nas.gamer.se 51. Okay, it looks okay. Connection is secure. Site has a valid certificate. So now we have verified that we can access the web service on the NAS using a fully qualified domain name, host name, and also the IP address. So yeah, that concludes this video, and I thank you for watching.